What's up, everybody? So today we are going to continue working on percent problems. We remember have kind of moved on from rates and ratios, but not entirely, because percents and fractions and all of these things are rates and ratios problems. So today's learning target would be, I can continue, because we started yesterday, so I need you to be able to remember and react to what you've already done. I can continue to solve percent problems using my ability to scale up and scale down. Okay? So if you can do those things, you'll be fine. Really, it's all about going up and going down, going up and going down. If you have 100%, can you cut it in half to make it 50%? Can you cut it down to 25%? Can you cut it down to 20%? If you have 40%, can you cut it to 20%, make it 100%? It's going down and up, down and up, down and up, working with any number between 100 and 0. So here we go. Solve the following 3% problems, 60% of 300. Okay? So let's go ahead and get started on that. So what is 60% of 300? Well, what we got to do here is figure out what these two numbers are. So 60% would equal what? That's what we're asking. What is 60%? Well, we don't know what that is, but we know what 100% is. What would 100% be? In this case, it's saying that that is equal to 300. Okay? So it's saying that 60% is what we want to know, of 300 being the total. So if 300 is a total, 100% is a total, 100% 300. So we got to go ahead and scale down until we can get to 60. Now, we can scale down until we get to a number which we can figure out is equal to something that we can scale back up to 60. Or we could just cut it in half, cut it in half, cut it in half until we get to something. The easiest way is probably going to be to take it down to either 10% or 20%. When working with percentages, if you can get it down to something you know that you could easily work with, how many times does 10% have to be there to make 100%? 10 times. How many times does 20% have to be there to make 100%? 5 times. So if you can get to those two numbers, then you can solve almost anything. That being said, let's go ahead and figure out what 10% is. Okay? What would that equal? It's just a rate and a ratio, right? So there's a ratio, 100 to 300. How do we get from 100 down to 10? It's simple. You divide it by a number. You're scaling down. You scale down by 10. So 100 divided by 10 is equal to 10. If that's true, then we're going to divide this by 10 also. What's 300 divided by 10? It's 30. So 10% is 30. Well, if we say that 10% is 30, then all we need to do is take from here and multiply it by what? How do we get from 10 to 60? Times 6, right? So then you just do this. This to this would be also times 6. What's 30 times 6? It's going to be 180. So that's easy enough. The answer here is 180. Now, let's move on. The next problem that we're going to be working with, I drew this red line so that we can see what we're working with now. Here, I will connect it here. There we go. Boom. The next one we're going to be working with 60% of 300. 60% of 300. So what I'm seeing here is that 60% is what we want to know. So again, 60% is equal to, what is it equal to? Well, 60% is equal to 300. So I don't know what the 100% is. I don't know what 100% is. What it's trying to get me to say here is what this number is. See this question mark right here? That's what this blank spot is. So 100% is equal to what? Well, easy enough. We can take this 60 down to something that we can get to 100 with. So what can we get 60 down to that we can get to 100? We can either get it down to 10 or we can get it down to 20. Getting down to 20 would be a lot easier. So let's go ahead and say we're going to come down from 60% to 20%. How did I get from 60 to 20? I divided by 3. Divided by 3. And I know that doesn't really look like a divided by, but divided by 3 is 20%. And so 300 divided by 3 is equal to what? Why did we divide it by 3? Because we took 3 here. It's equal to 100. So 20% is 100. So then what would 100% be? How do I get back from 20% back up to 100%? Easy enough. We just multiply times 5. Times 5. So 100 times 5. And the answer is going to be 500. Okay, so once again, I'm going to draw this red line just to show that we're working on this last problem here. Okay, 60 out of 300 is equal to what percent? So what we're saying here is that what's the total? Well, easy enough. The total is 300. So what's total in percent? 100% is equal to 300. And we want to know what 60 is. Is that 60%? No. See, here and here, we've been working with 60%. But we're not working with percent. We're just working with 60. So that's going to go under just the normal number side. So what is 60? How did we get from 300 to 60? And that'll tell us the percentage. So easy enough, okay? We can figure out what we divided by. Or we can do it the way that I would probably do it if I was me, okay? And the way I would do it if I was me is I would go ahead and just break it down and get smaller and smaller until I knew something, okay? So basically I'm just making a table. Well, I'm going to cut it in half. 50% would be half of 300, which I know is 150, okay? Is that 60 yet? Are we to 60 yet? No, we're still at 150. So I'm going to cut it in half again and say that's 25%. Well, half of 150 would actually be 75. Pretty sure. Double check on a calculator. Yep, 75. So are we there yet? No, not at all. So I know that 60 is less than 25%. Okay? Well, here's what I'm going to do now. I'm going to go ahead and figure out what 5% is and see what I can do from there, because I know I can get from 25 down to 5%. See, from here to here, we divided by 2. And again, from here to here, we divided by 2. And from here to here, I'm going to divide by 5. I'm just scaling down, flexibly scaling down by different amounts of numbers. Okay? And so then I need to divide this also by 5. So 75 divided by 5, I'm going to use my calculator, is 15. Okay? Now, can I get from 5 up to 60? Can I get from 15 to 60? I know that I can. Okay, how did I get from 15 to 60? Easy enough. It was times 4. Okay, it went back up. Up is multiplication. So I'm going to multiply this times 4. And 5% times 4 is 20%. So 20% is 60. So the answer here is 20%. And I know that's kind of confusing, but if you need to rewatch a video, we're scaling down, scaling up, scaling down, scaling up. That's all percentages are. Okay. How did you solving method differ for each problem? So this first one right here that we're going to be talking about, all I had to do was figure out how to get from the total down to a number I knew how to work with. Okay. And working with percentage sides, and then bust that back up to 60. Okay, so scale down, scale up. And this one, I knew what 60% was, so what I had to do was scale down to a number that I could work with. Not the unit rate, because it's not 1, but close to a unit rate in percentages. And I had to bump that back up, so scale down, scale up. And in this one, I had to scale down, scale down, scale down, and finally scale up. So I guess they differed only with what I was focusing on, but I always scale down and scale up. That's always my way of solving. Scale down, scale up, scale down, scale up. Okay. So now it says using models such as a 10 by 10 grid, ratio tables, tape diagrams, or double number line diagrams, solve the following situations. I'm probably just going to use a ratio table because that's what we did up here. These are just ratio tables. So let's go ahead and take a look here. Priya is doing her work back to school shopping. Calculate all the missing values in the table below, rounding to the nearest penny. Okay, so we're working with money, 6th grade money. And calculate the total amount Priya will spend on her outfit after she receives the indicated discounts. So let's go ahead and figure out the price of the discount here. So we're trying to figure out what 25% of 44 is, okay? This was the original price. We're trying to figure out the discount, not what she paid, just how much the discount is. So let's go ahead and just work right here. 44 is what? That's the total. That's 100%. And we want to know what 25% is. So all we had to do here was scale down. We're trying to figure this out right here. So scale down, how do I get from 100 to 25? Well, if this was decimals, it'd be $1 and 0.25. So it's a quarter. A quarter is 4, so I had to scale down by 4. So then I also scale this down by 4. What's 44 divided by 4? I can do that in my head. It is 11. So the price of the discount is 11. So she wouldn't pay for the $11. She would end up only paying $33. Okay, that was that one. Box that in. Let's go ahead and look at pants. So pants, we don't know the original price, so we don't know what 100% was equal to. We don't know what that was. We're actually trying to find that. We know that $15 was equal to 30% discount. And I know that because it's right here, okay, 30%. So 30% was 15. Can I easily get from 30 to 100? I can't. So what we're going to do is we're going to go down, scale up. What's something we could get to? Could we get to 20% easily? We can't. So can we get to 10% easily? Absolutely. Here we go. Let's go down. How do we get to 10%? We divide by 3. So also divide this by 3. Look at there. It's 15. So it's easily divisible by 3. That gives me 10%. And 15 divided by 3 is 5. So 10% would be 5. Now what we're going to do is we're going to come all the way back up to 100%. How do I get from 10 to 100? Just times 10. So I'm going to multiply this times 10. And what do I get? I get 50. 5 times 10 is 50. So the pants originally cost $50. That's not a very good pair of pants. It's expensive. All right, I'm going to box this in, and I'm going to move on. Okay, so $15 discount on the shoes. I'm going to work right here for this one. Okay, so it was a 15% discount on $9. So 15% discount was $9. We want to know what 100 is. How much were they originally? So can I get from 15 to 100 easily? No, I cannot. So what I'm going to do is get to a number I can get to easily. What's a number that I can get to 100 easily with? That is in 15. Probably 5. So let's go ahead and look at 5%. And how did I get from 15 to 5? How would I go about doing that? Divide by 3. So I'm going to divide this also by 3. And look at there, it's like that's what they wanted you to do because 9 is divisible by 3. 9 divided by 3 is 3. Now, here's the crazy part. We're going to have to get all the way from 5% to 100%. How do we get from 5 to 100? Easy enough. You multiply by 20. Okay. So 5 times 20 is 100. So we just need to multiply this by the same thing. What are we multiplying that by? By 20. 3 times 20 would be 60. That is a very cheap pair of shoes. Her shoes only cost $60. All right. Now this one's going to be very easy. Okay. It's 10% on $20. So this original price is actually going to be the total, right? This is what 100% would be. This is supposed to be saying total, but it looks like it says total. Okay, total. So this right here, the original price is total. So 100% is going to be, let's do this one in blue. 100% is going to be $20. And we want to know what 10% is. So what's 10% going to equal? Well, if you ever have worked with tens, you know that all I need to do to get from here to here is divide it by what? 10, okay? Which really just crosses off one of the ones places. It takes away a place value. And so what we would do here is divide this by 10. You can do this on a calculator very easily, or you could just say take out the place value. 10% is $2. She's going to save $2 on a necklace that costs $20. I think that she doesn't really need a necklace for school, but Priya has her own priorities, so let her do her thing. Last one, sweater. It's a 20% discount, okay? So not the total, but 20% is equal to 7. So let's box this in. 20% is equal to 7. We want to know how much the original cost was. So the full price would be 100%. Now this is very easy because remember I told you want to get from 20 or 10. So how do we get from here to here? We multiply it by what? By 5. So we're going to multiply this by 5. And so 7 times 5 is 35. So she originally would have paid $35 for this sweater. I don't know where she's shopping. Old Navy has better prices, but whatever. $35 for this one. Got to put that dollar sign in there. And then what was the total cost of Priya's outfit? Now, it doesn't say how much did she save. It doesn't say how much did she would she have spent without discounts. It says how much did she spend. So what we're going to do here is we're going to take these and subtract them. So she would have spent 44, but she didn't spend 11 of those. So what did she end up spending? For the shirt, she only spent $33. This is great. Let's go ahead and do the shoes in the pants in pink, okay? So she would have originally spent $50, but she didn't spend 15 of that, so she only spent 35 on that. Let's do the next color in red since it's already kind of in red. Shoes, she would have spent $60, but she didn't spend 9 of it, so she only ended up spending $51. Let's do the next one in blue because it's already blue. She would have spent 20, but she didn't. She saved $2, so she ended up spending 18. And lastly, her sweater should have cost $35, but instead of costing $35, we'll just do black marker on this one. Instead of $35, she saved $7, so that actually made it $28. Ooh. Okay, I will get rid of that. $28. So how much did she spend altogether? 3 plus 5 is 8, 9, plus another 17, 18, 19, 20, 25. So the ones place adds up to be 25, carried 2. And then we've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, $16 in the tens place. So Priya spent $165 on one outfit. Oh my Lord, Priya, you could save some money, girl. All right, moving on. So now you are working on the problem set. There's only 2 problems that I can see. They shouldn't be too difficult. So this is what you are doing today. All right, any questions at all? Go ahead and email me. If it's way too hard to do this problem set, you just have to show me that you tried, and I'll give you a grade for it. Have a fantastic day.